Today in this video, we are going to see the logical and critical thinking lab experiment 2, that is categorical logic and syllogisms. So here we need to know what is the categorical logic. So categorical logic statement is termed as a proposition. So a proposition is a statement that either be a part of the set, or it may be the whole of the objects or the set of objects that is present in a statement or a set of information. So the set identified by the subject term in the sentence expressing that statement, either it must be included or it should be excluded in the statement. Another set is the set identified by the predicate term in that sentence. The standard form of a proposition. So the standard form of a proposition is quantifier, subject, copula, and predicate. So the proposition consists of all these four parts. Quantifier is like the words all, no, and some, because that will specify a quantity. All and no are universal quantifiers because they refer to every object in a certain set, while the quantifier sum is a particular quantifier because it refers to at least one existing object in a certain set. Subject, it is denoted by S. The subject is that about which something is said. Predicate is denoted by P. The predicate is the part of the proposition denoting that which is affirmed or denied about the subject. Copula is that part of proposition which denotes the relationship between a subject and a predicate. So here if we see the example for the standard form of a proposition, the first example is all men are animals. Here all is a quantifier, men is a subject, are is a copula, and animals is a predicate. If we see the second example, some pens are erasers. Here some is the quantifier, pens subject, erasers predicate, are is a copula. So the fourfold classification of propositions, we all have discussed this in before class. A proposition is said to have a universal quantity if it begins with a universal quantifier, and a particular quantity if it begins with a particular quantifier. So we all know the quantifier is the word that we use. It's like before a sentence, all, some, no, none, all these are quantifiers, right? Besides proposition, which asserts something about the inclusion of the whole or a part of one set in the other, are said to have affirmative quality, while those which deny the inclusion of the whole or a part of one set in the other are said to have a negative quality. So also a term is distributed in a proposition if it refers to all members of the set of objects denoted by the term. Otherwise, it is said to be undistributed. Fourfold classification of propositions we all know: universal affirmative, universal negative, particular affirmative, and particular negative. Universal affirmative proposition, it is denoted by A. It distributes only the subject. So that is, the predicate is not interchangeable with the subject while maintaining the validity of the proposition. If we see the example here, all snakes are reptiles. So this is a proposition of universal affirmative proposition, the validity. So here if we see, we cannot say all reptiles are snakes. And the second one is universal negative proposition. It is denoted by E. It distributes both the subject and the predicate. That is, an entire class of predicate term is denied, or the entire class of subject term as in proposition. If we see the example, no boy is intelligent. Particular affirmative proposition, it is denoted by I. It distributes neither the subject nor the predicate. If we see the example here, some men are foolish. Here, the subject term men and the is used not for all but only for some men. And similarly, the predicate term foolish, it is affirmed are a part of subject class. So both are undistributed. If we say the particular negative proposition, it is denoted by O. It distributes only the predicate. Example, some animals are not wild. Here the subject is animals. It is used only for a part of class and hence is undistributed. While the predicate term wild is denied in entity to the subject term and hence it is distributed. And if we see the table here, this is the statement form we are seeing here. And this is the quantity and this is the quality. So if we take the example, all S is P, it distributes only the S. If we see the example, no S is P, both S and P are not distributed. Some S is P, so it is like particular affirmative, neither S nor P. Some S is not P, here P only. So here if we see, it is a particular negative. Coming to logical deduction, it is a phenomenon of deriving a conclusion from a single proposition or a set of given propositions is known as logical deduction. The given propositions are also referred to as the premises. Two inferential process of deduction. So one is immediate deductive inference. Here the conclusion is deduced from one of the given propositions by any of the three ways. So the first way is conversion, and the next one is abortion, and the last one is contrapositive. Coming to conversion, the conversion proceeds with interchanging the subject term and the predicate term. That is, the subject term of the premises becomes the predicate term of the conclusion, and the predicate term of the premise becomes the subject of the conclusion. The given proposition is called, if we take a statement, that is called convertent, whereas the conclusion taken from that statement is called its converse. So if we see here the examples, all S is P, all pins are tops. So when we converse it, some P is S, some tops are pins. If we see here, the subject is pins and the predicate is top. So when we see into the conversion, the conclusion that is derived from the convertent, so the interchanging of both the subject and the predicate we can see, right? So the next example is no S is P, no P is S, no fish is whale, no whale is fish. And the next example is some S is P, some P is S. Some boys are poets, some poets are boys. And the last example is some S is not P, and this is not a valid conversion. We cannot do a conversion using this statement. And the next one is abortion. In abortion, we change the quality of the proposition and we will replace the predicate term by its complement. If we see here, all birds are mammals, and the answer is no birds are non mammals. So here, no poets or singers. The answer will be all poets are non singers. And some nurses are doctors, some nurses are not non doctors. Some politicians are not statesmen, some politicians are non statesmen. And coming to contrapositive, contraposition. To obtain this contrapositive of a statement, we first replace the subject and the predicate terms in the proposition, and then we will exchange both the terms with their complements. So, coming to the example here, all birds are mammals. So, all non mammals are non birds. Some birds are mammals, some non mammals are non birds. So if we see here, we should note that the valid, converse, obverse, and contrapositive of a given proposition always logically follows the proposition. And coming to the second one, mediate deductive inference syllogisms. So it is first introduced by Aristotle. A syllogism is a deductive argument in which conclusions has to be drawn from two propositions referred to as premises. So here if we see the both the statements, these both are called two propositions or premises. The first one is all lotus are flowers and all flowers are beautiful. The conclusion we derive from these two propositions is all lotus are beautiful. So here, if we see both two propositions are called as premises, the first and second statement, and the third one is the conclusion that we derive from the statements 1 and 2. And the term, it is a word or a combination of words which by itself can be used as a subject or predicate of a proposition. Syllogism is concerned with three terms. One is major term, minor term, and middle term. So the major term, it is a predicate of the conclusion and is denoted by P. And P is the first letter of the predicate. And the minor term, it is the subject of the conclusion and is denoted by S. We all know subject starting letter is S, so it is denoted by S. And the middle term, it is a term common to both premises and is denoted by M. So here if we see the example here, the premises statements are one is all dogs are animals, and the second statement is all tigers are dogs, and the conclusion is all tigers are animals. If we see here, animals is the predicate of the conclusion, and so it is the major term P. So tigers is the subject of the conclusion, so it is the minor term S. So if we see here, dog is a term common in both the premises. So it is the middle term that is denoted with the letter M. And major and minor premises. So these two premises, the major premises is that in which the middle term is the subject, and the minor premises is that in which the middle term is the predicate. So we have the rules for deriving conclusions from two given premises. The first rule is the conclusion does not contain the middle term. So if we see here, the common term that is present in both the statements is girls, right? So the first statement is all men are girls, and the second statement is some girls are students. And in conclusion, all girls are men, some girls are not students. So both the conclusion contains the middle term. So neither of them will come under this rule. And the second rule is no term can be distributed in the conclusion unless it is distributed in the premises. So if we see this example, the first statement is some dogs are goats, and the second statement is all goats are cows. In conclusion, all cows are goats, some dogs are cows. In statement 1, it is an I-type proposition which distributes neither the subject nor the predicate. And in statement 2, it is a A-type proposition which distributes the subject, that is goats only. So in conclusion 1, it is a A-type proposition which distributes the subject cow only. Since the term cows is distributed in conclusion 1 without being distributed in the premises, so conclusion 1 will not come under this rule. And the third rule is the middle term should be distributed at least once in the premises. Otherwise, the conclusion cannot follow. For the middle term to be distributed in a premises, so there are three things that we should follow. M must be the subject if premises is an A proposition. M must be the subject or predicate if the premises is an E proposition. M must be predicate if premises is an O proposition. We all know what A, I, and E, O, all this denotes, right? So we have to note that in an I proposition which distributes neither the subject nor the predicate, the middle term cannot be distributed. Coming to the example, if we see the statements here, all fans are watches, some watches are black. In conclusion, all watches are fans, some fans are black. In the premises, the middle term is watches. You can see clearly. So it is not distributed in the first premises, which is an A proposition, as it does not form its subject. Also, it is not distributed in the second premises, which is an I proposition. Since the middle term is not distributed even once in the premises, no conclusion will come under this rule. And the fourth rule is no conclusion follows. And there are few cases and no conclusion follows in this rule. And the first example is the statements that are present is some books are pens. And the next statement is some pens are erasers. And the conclusion, if we see all books are erasers and some erasers are books. Since both the premises are particular, so if we see some quantifier, it is comes under particular. So we cannot say which is definite conclusion for this. And the next case is if both premises are negative. If we see the example here, the statement contains no quantifier, right? No flower is mango, no mango is cherry. And the conclusion here is no flower is cherry. So some cherries are mangoes. Since both the premises are negative, we cannot say which is the conclusion. Maybe both may be, neither conclusion follows. So if the major premises is particular and the minor premises is negative, if we take this case, if we see the statements given, some dogs are bulls, no tigers are dogs. The conclusion is no dogs are tigers, some bulls are tigers. So here the first premise is containing the middle term as dogs, right? This is the first premises. As the subject is the major premises and the second premises containing the middle term dog as the predicate in the minor premises. So since the major premises is particular and the minor premises is negative, we cannot conclude from these statements. And the fifth rule is if the middle term is distributed twice, the conclusion cannot be universal. If we take this example, all fans are chairs, no tables are fans. In conclusion, no tables are chairs, some tables are chairs. Here, the first premises is an A proposition, and so the middle term is fans, forming the subject is distributed, and the second premises is an E proposition, and so the middle term here is transforming the predicate, right? So it is distributed. Since the middle term is distributed twice, so the conclusion cannot be universal, right? And the next rule is if one premises is negative, the conclusion must be negative. Here, if we see all grasses are trees, no trees is shrub. So the conclusion, no grasses are shrubs, some shrubs are grasses. Since one premises is negative, the conclusion must be negative. So This cannot be the conclusion. And the seventh rule is if one premises is particular, the conclusion must be particular. So if we these statements, some boys are thieves, all thieves are dacoits. In the conclusion, some boys are dacoits, dacoits are boys. So one premises is particular and the conclusion must be particular. So it will be the answer. Two conclusion cannot come under this rule. So the eighth rule is if both the premises are affirmative, the conclusion must be affirmative. If we see this example, the both the statements quantifiers is all. All women are mothers, all mothers are sisters. In conclusion, if we see all women are sisters, some women are not sisters. Since both the premises are affirmative, the conclusion must be affirmative. So here the affirmative is all right. So the second conclusion will not come under this rule. And the ninth rule is if both the premises are universal, the conclusion must be universal. So, and the complementary pair, it is a pair of statements such that if one is true, the other is false, and when no definite conclusion cannot be taken out of those statements, either of them is bound to follow is called a complementary pair. So here E and I type propositions together form a complementary pair and usually either of them follows. In a case where we cannot arrive at a definite conclusion using the rules of syllogism. So if we see here, we are using a verification using Venn diagrams. If we take the case 1, all men are boys, all boys are students. So if we take immediate deductive inference, so the converse of first premises is some boys are men and the converse of second premises is some students are boys. So both holds, right? And the immediate deductive inference is since both the premises are universal and affirmative, the conclusion must be universal affirmative. Also, the conclusion should not contain a middle type. So it is like all men are students. If we see here, the boys is the middle term, right? Boys should not come in the conclusion. And here it is universal affirmative. We are using a quantifier called all. All men are students. The converse of this conclusion is some students are men. So if we see the Venn diagram, so all the statements will be there in this diagram. So if we see men, sorry, all men are boys. So if we see all men comes under boys, right? So all boys are students. So all boys comes under students, right? So this is the Venn diagram, how we represent these two statements. From this, what are the inference statements we are deriving is some boys are men. Yes, right? Some boys are men. And some students are boys, right? Some students are boys. And all men are students. So in students, it is there. This set is there, men's set. So all men are students. It is true. Some students are men. If we take some students, they are men, right? Yeah. And the next case is all birds are animals, all fishes are animals. So if we see both the statements, from this the immediate deductive inference is the converse of this first statement is some animals are birds and the converse of this statement is some animals are fishes. So the mediate deductive inference is both being A-type proposition distributes subject only. So the middle term is not distributed even once in the premises. So no definite conclusion will come out of this, right? So if we take the Venn diagrams, it may be both. So if we take here, all birds are animals, all fishes are animals. So both Venn diagrams may come under this. So some animals are birds and some animals are fishes. So either no bird is fish or some birds are fishes. So this is the complementary pair that comes under E and I type propositions. And the next case is all puppets are dolls, some dolls are rattles. In this immediate deductive inference is some dolls are puppets for this converse statement and some dolls are rattles. This converse statement is some rattles are dolls. So for mediate deductive inference, the first premises is A type proposition. It distributes the subject only. And while the second premises being an I type proposition, it distributes neither subject nor predicate. Since the middle term dolls, so here you can see the common term is dolls, right? It is not distributed even once in the premises. So we cannot conclude a definite conclusion with these statements. So this is the Venn diagram for this, and these are the inferences statements that comes out of this premises. So coming to next case, some writers are players, all players are musicians. So here the immediate deductive inference is the first premises converse is some players are writers and the converse of second statement all players are musicians is some musicians are players, and the mediate deductive inference is one premises is particular, the conclusion must be particular and should not contain a middle term. So it follows that some writers are musicians. The converse of the conclusion is some musicians are writers. So if we see this is the Venn diagram. So some players are writers. If we see some players are writers, yes, it is true. And some musicians are players. And here if we see some musicians are players, it is true. And some writers are musicians. Yeah, some writers are musicians. And some musicians are writers. Some musicians are writers. So coming to next case, all boxes are toys. Some boxes are clips. These are the two premises, that is statements. So from this we have to derive the immediate deductive inferences and immediate deductive inferences. The converse of the first premises is some toys are boxes and the converse of second premises is some clips are boxes. So the next one is mediate deductive inference. In this one premises is particular. So you can see some, right? That is particular. The conclusion must be particular and it should not contain the middle term, right? So here the middle term is boxes, right? So it should follow like some toys are clips. The converse of this conclusion is some clips are toys. So if we see the Venn diagram, from this what we derive is some toys are boxes. Yes, some toys are boxes. Some clips are boxes. Yeah, some clips are boxes. And some toys are clips. Yeah, some toys, you see here, those are clips. And some clips are toys. So some clips are toys here. And coming to the sixth case, all buses are vans, some cycles are vans. So here if we see, here the converse of first premises statement is some vans are buses and the converse of second premises is some cycles are vans, so some vans are cycles. So here it is an A type proposition. The first premises it distributes only the subject and the second premises is I type proposition. It distributes neither subject nor predicate. So the middle term Vance is not distributed even once in the premises. Here we cannot draw a definite conclusion. So this is how Venn diagram, and these are the conclusions that we conclude using inferences. And the seventh case is some radios are cameras and some cameras are statues. Here the converse of first one is some cameras are radios and the converse of second premises is some statues are cameras. So it consists of both premises are particular. So we cannot conclude a complete or a definite conclusion out of this. So the eighth case is all cakes are candies, no pastry, no candy is pastry. So here the some candies are cakes and no pastry is candy. So here if we see this premises are both are universal. So the conclusion must be universal. Either it should come one is negative and the other is, so the conclusion must be negative. So no cake is pastry. The converse of this conclusion is no pastry is cake. So if we see the inferences we get is these statements. And the next case is no coin is ring, all rings are bangles. So here if we see the first we are seeing like immediate deductive inference is like we are declaring converse statements out of the given premises. And the immediate deductive inference is based on the affirmative propositions or the negative propositions we are deriving, is it distributed or it is undistributed. Based on that we conclude a statement, and then that statement we are changing it into conversion. So that is how we are deriving Venn diagrams from the statements and the inferences out of it. And the 10th case is some lamps are candles and no candle is bulb. Here, if we see the converse of first premises is some candles are lamps, and the converse of second premises is no bulb is candle. So both holds, and the mediate deductive inference is one premises is particular and the other is negative. The conclusion must be particular negative. So that is O type. So it follows some lamps are not bulbs. And the important points that we should remember here is while deriving logical conclusions, always we have to remember like the converse of each of the given premises and the conclusion that directly follows from the given premises in accordance with the rules of syllogism, the converse of the given derived of the derived conclusion and the syllogism. So the question which are asked in this section contains two or more statements, and these statements are followed by two or more conclusions. So we have to find which of the conclusion logically follows from the given statements. The statement have to be taken true if they seem to be at variance from the commonly known facts. Like if we take the help of Venn diagrams on the basis of given statements, we should draw all the possible diagrams and then derive the solution from each of the diagrams separately. So finally, the answer common to the all, the diagram is taken. So if we see the syllogism, so if we take an example, here if the statements are all dogs are asses, all asses are bulls. And the conclusion here we have given is four conclusions they have given. Some dogs are not bulls, some bulls are dogs, all bulls are dogs, all dogs are bulls. So in this, on the basis of both the statements, if we see here, we have drawn the Venn diagram here. So It is like all dogs are asses and all asses are bulls. This is the Venn diagram that we have taken from the statement. So from this, we have to see the conclusions which is correct, right? Some dogs are not bulls. Some dogs are not bulls. No, right? And some bulls are dogs. So if we see some bulls are dogs and all bulls are dogs. All bulls are dogs. No, it is not correct. All dogs are bulls. Yeah, this is correct. So from this conclusions, from the Venn diagram, what we conclude is the statement 2 and the statement 4 both are logically correct. And the second example is if we take here the statements some dogs are asses, some asses are bulls. So the conclusion here is some asses are not dogs, some dogs are bulls. So from this given statement, the following these are the diagrams that are possible for these statements and the conclusions. So here the diagram 1 and the conclusion 2 it will follow, right? This is how we derive Venn diagrams and the statements out of the premises. And this is the experiment 2, that is categorical logic and syllogism